हम तक पे sir? No more. At Spring Library, we explain every topic in simple way. Join the learning family and score high every day.
Okay, in this problem we have a bear chasing a man and he's trying to get to his car. Or a tourist, it could be a woman, but that's more letters. So a bear is chasing a man and he's trying to get to the car, and we're trying to find the maximum distance when they reach the car at the same time. The car has a magical portal, and obviously the man is able to get into the car lickety-split in no time at all. So that's the assumptions that we're making. So here it says D max, but I'm going to write a little bit more. I'm going to say D max when time to reach the car is equal, the same. That's the key. That's the insight that you need in order to solve this problem. From here, we're going to go ahead and just simply write the solution. The solution is going to involve the fact that we're going to have here the velocity is equal to the distance divided by the time, which is great. But, we're looking at this. We're looking at the fact that the time is equal for both. So I'm going to solve this one for time. Time is going to be equal to the distance divided by the velocity. I get that by multiplying both sides by t and dividing both sides by v. T's over here cancel, v's over here cancel. I end up with this equation here. Okay, so this equation is going to give me what? This is going to say this time is the same for both, and it is going to be equal to the distance of the man divided by the velocity of the man, equal to the distance of the bear divided by the velocity of the bear. What am I solving for? Well, here's what I'm looking for right here. I'm looking for the distance of the man, which is d. So let's go ahead and solve this equation for the distance of the man. To do that, I'm going to do pretty much the same thing as I did over here. I'm going to multiply both sides by the velocity of the man on both sides. And that is going to cancel over here, so I end up with the distance of the man is equal to the distance of the bear multiplied by the ratio of their velocities. The velocity of the man divided by the velocity of the bear. Okay, if you followed me to this point, we can go ahead and now substitute the numbers in. So what is the distance of the man? That is d max, because they have the same time. Okay, so d max is when time are equal. Okay, the distance of the bear is going to be equal to d plus 26. And then we have here the velocity of the man, which is 4, divided by the velocity of the bear, which is 6. This is wrong, actually, and the reason why it's wrong is because you have to multiply the d plus 26 times the 4/6, not just the 26. The d plus 26 is the distance of the bear. All right, and then here I'm going to go ahead and just subtract or erase the fact that this is d max because it's simply d in the problem. In order to solve this, I am going to take it and rewrite it. So I'm going to say that d is equal to d plus 26 times 4/6, and then I have a parentheses around this as well. I want to multiply both sides by 6, and you end up with 6d is equal to, multiplying this out, I end up with 4d plus 26 times 4, which is 104. All right, I'm going to subtract 4d from both sides, and I end up with 2d is equal to 104. Therefore, d, which is d max when the time is equal, is going to be equal to 104 divided by 2, which is 52 meters. I should put in here that it assumes a magic door. And we're done.